Hello. Hi everyone. Just doing a quick sound check. Sound seems all right. I think I've said it before, but every lecture theatre is a little bit different. Ainsworth and stuff is like usually not very good. Test. Okay, that'll do. Hi. Welcome to week 7. I'm actually surprised to see so many of you here. I feel like there was less of you in week 5. Am I crazy?
Probably pretty burnt out by week 5.
Yeah, I've never actually seen a cohort of people where there's more students in week 7 than week 5. So this is quite remarkable. I expected to come here with like 4 people here, but turns out many of you here. So congrats, let's have a fun little time today. I'd also like to say I'm even more impressed, not just because there's more than last week, but also because you have your iteration 2 due on Friday, right? Yeah, 4 days? 4 days to go, 100-ish hours, something like that, 108 or whatever. I also know, just because I spent some time this morning trying to catch up on a few things, because obviously I'm not running the course this term, so I'm not like across all the details. But I was having a look at the leaderboard scores. Who's seen the leaderboard results yet? I don't know if they were published yet. They're not published yet. Okay, so I'll give you a sneak peek. There's not a lot of great results in the leaderboard. Now, the reason I wanted to point this out is because that's actually, firstly, it's kind of normal at this point in term, because iteration 2 is notably harder for students than iteration 1, right? So it's a little bit clunkier to get started. And secondly, that's kind of normal. So if you kind of see a leaderboard result that's like, 0 to 10 or 20 to 30 or something lower than you'd expect, all I want to do is reassure you that like that's not an unfamiliar environment to be in, and many other students are in that group at this point. And a lot of groups are there because they just actually haven't gotten that amount of work done yet either, right? So just keep an eye on that. Secondly, when it comes to the leaderboard, obviously they run on Mondays, Wednesdays, and Fridays, unless something's changed. And when it comes to the Wednesday leaderboard, I'd probably take that one a bit more seriously. Really focus for that Wednesday leaderboard, because the Friday leaderboard's not super useful. Okay, you find out you got a result at midday. There's not a lot you can do with that information. You probably know how you're going by midday, but the Wednesday one can be really useful. So put your hand up if your group hasn't really done much with iteration 2 yet. Good. Fun week. Fun week for those people. Yeah, it'll be fun. Just work, if you haven't really started too much at this point, just work quite hard on it. There is a reasonable amount of work to do if you're trying to do it in just 4 days. But again, a focus group can achieve quite a lot of things. Before we start, are there any questions people want me to address just before I hit record and we get into the lectures this week? I'm not putting up my Slido because you're the first cohort that's just decided you never want to post in it. So you can speak to me. Or I have the YouTube chat up for people online as well. Yeah, nothing. Okay. So you have won the award now of the least curious group I've ever taught, and also the highest attendance in week 7. So it's a bittersweet set of awards to win. Now, I will preface by saying that the lectures this week are not to do with iteration 2. I think we've been through this back in week 4 when you first had me, where I said the week 4 lectures have nothing to do with iteration 1, right? If you remember that. So that's good for you, because if you don't absorb stuff today, you have time to absorb it. No stress, no big deal, all good. And it's actually pretty light content today, I think. But particularly this lecture here, because this lecture here feels like it's kind of for iteration 2, but it's not. I gotta hit record. Oh, hopefully I don't run out of disk space again. Ooh, okay. I should check that out. Okay, so code coverage. Code coverage, who's heard the term before? Has your tutor mentioned it to you? Nothing? All right. It's a term that can be thrown around a bit. To some extent, its name might help you understand what it's about. Code coverage, how much of your code do you cover? What does covering it mean? Is it looking at it, not too sure? What we mean by code coverage, though, in the context of this course, is it's all to do with testing. In particular, it's a topic about how do we check how much of your code that you write, your implementation, is covered by the tests. It's an idea you probably, have an intuitive understanding of, right? You write tests with the idea that you want them to cover the code you've written or will write. That's why we write tests. If you write a bunch of tests that don't test the actual code you end up writing, you wouldn't consider them good tests. So I don't think I need to explain to you the importance of code coverage, because having a test that covers a lot of code is a good thing. The part of this lecture that's relevant is that we need a mechanism to test how our code is covered by the test, basically. Because it's not really about, you can look at it, but we need an automated, mechanical, systematic way to actually check that. Now we're going to talk about coverage in general, a little bit of a high level, but then we're mostly going to talk about code coverage and also coverage in jest. So firstly, coverage is a measure of how thorough our tests are. Makes sense. If our tests cover a lot of code, our tests have good coverage, and therefore our tests are thorough. One important distinction here is test coverage and code coverage. So this lecture is on code coverage, but there's another term called test coverage. And test coverage is a measure of how much of the feature set of things is covered with tests. This is often led by human discretion, human judgment. And this is actually probably how you've approached testing and implementations back in iteration 1 and even 2, is that you say, well, we've got to test auth, register and log in and creating a quiz and that, right? You think about it at a very block level, high level. You're kind of seeing what your tests cover, right? So think of that one as high level, a bit more qualitative. A human can mostly do it. It's how your tutors actually look at probably your code when they read it, right? They look at your test and they go, yeah, I can see a test for this and a test for this and a test for that. Whereas code coverage is a measure of how much code is executed whilst the testing is being run, and this can be computed and quantified. So this is a quantitative approach, this one here. Now, code coverage, typically what it does is it measures code coverage as a percentage of lines executed. So you imagine that your implementation, get all your implementation files, auth.ts, quiz.ts, you stack them all up and they might be like, I have no idea, 600 lines of code, right? No sense of how big it is. If your tests, whilst running, execute 500 of those 600 lines of code, then you would express your code coverage as 5 out of 6 or what's that, 83%, something like that. You would say like, oh, it's 83% covered, right? That's the quality of our code coverage. And it's a great way to give us a good indication of how much of our code is executed. It helps you really understand, like, because if you see code that your tests don't ever execute, that's kind of code that's in your blind spot, right? That's code that maybe there's a bug in there and your tests would never find it out. So it really helps identify where code isn't done. It doesn't really help us figure out where we've written too many tests or unnecessary tests, because once you've checked all of your implementation, it's just 100. So if you get 100% code coverage and then you double the amount of tests you have, it's still going to be 100%. So it's really about where you undercook your tests, not really overcook it. So it's all about that undercooking element. One of the cool things about code coverage in JavaScript, and it's actually really great and easy, is that it's actually really easy to do. It's a little harder with servers. There's some code we give you for iteration 3 to kind of do coverage with servers, but this lecture is just on simple JavaScript stuff. So think like iteration 1 before we did HTTP. But it's really easy with Jest, because Jest actually has a code coverage capability built into it, where we simply have to add a flag to Jest and it will give us some coverage information. So what I've got here is we've seen this piece of code before, right? I don't know if I was the one teaching you for it. I'm sure it was you, Chow. Is leap year, takes in a year. You got all the classic leap year rules, very confusing, very strange. And it returns a result. OK, sure. It's a great little example of a piece of code to test code coverage on, because there's a lot of branching. There's a lot of if statements, else statements, and stuff like that. So, and we've also got this piece of code here. Now, what we're going to do, just make sure I'm not too far ahead. Yeah, so we're going to run Jest coverage to run the test. So what I've got is I've got our code up here. I've got is leap year, and I've got data year here. And in my package.json, you can see that I've got Jest here. So what we're going to do is we're going to try and write our own little test for this and modify it as well. I'm going to go grab a test back from week, whenever we did testing. Yeah, I'll just grab a bit of code here. So a bit of live stuff today, lots of fun. We'll call this we'll do it is leap year test. So I make it is leap year.test.ts like this. And what we'll do is we'll import our function. So inside is leap year, we've got our is leap year function. So we'll import that from is leap year. Cool. Now, again, just my friendly reminders when I program and stuff. I like to never, if I can, write much code that's complicated at the start. I usually like to write really simple code like this. And I will go and run that code, just my kind of usual life tip. So that's the Jest I'm going to run. It's not testing anything, right? But I don't even know if I've written the Jest properly, right? We don't write Jest every single day of the week. So I'm simply going to bring that up on the command line here. I'll go inside my today's lecture. I have to npm install this one, so give it a sec. Shouldn't be too complicated, because there's not too much to install. Is anyone getting sick of the rain yet? I'm getting sick of the rain. npm run Jest should work hopefully on is leap year .test.ts. Let's have screwed something up. OK, all tests passed, right? Of course, because we didn't do anything. But at least I know my code runs now. So I haven't screwed up any of the infrastructure. So now what we can do is we'll simply call well, I expect that if I call is leap year on, say, the year 2000, that it should be a leap year. Make sense? Who wasn't born? Who was born after 2000 here? Damn. Okay. That's not good. All right. Well, 2000. I want to pick one you remember. Remember 2008? Remember that leap year? Yeah. I don't think you're that young. So okay, 2008's a leap year. Cool. Now we get that. We get jest. But here's where things get more interesting. Obviously, if I go back to my package.json here, in this case, when I write jest, it's going to run the jest command. Okay. But if I add a -- coverage here to the jest command, when I run this now, because remember npm run jest looks up the script jest, I get more output. In particular, I get this little breakdown here, which is quite interesting, where it says, okay, well, here are all the files that I did the coverage checking on. In particular, it's gonna basically stack up all the, like if this makes sense, you've got tests you run, and they go across all of your implementation files. And what jest coverage will do is look at all those implementation files, count up all the lines that the tests you run touched when it did the testing, and just write you a little report here. We only have one file in this case, which is isleapyear.ts. And what we do with that is we see, okay, 50% of the statements were executed. In particular, the lines that weren't covered was lines 3 and lines 6 to 9. So if I open up this file here, it's saying, hey, we didn't touch this line here, and we also didn't touch lines 6 to 9 either. So it's kind of telling us which lines our test did not touch. It does say that we touched 100% of the functions. That's obvious because there's only one function in this file. If I wrote another function called blah that did nothing except console log blah, you would see that if I ran this again, you would see a different result. You would see now only 50% of the functions were touched by the tests, as opposed to 100% of the functions. If I added a whole other file to this folder called blah, which simply exported another function called blah, that console logged blah, you'll see when I run this now, we're going to have another file. Oh, should have. OK, sorry, it only shows the files we touched. But I think if we import it, let me just double check I've got my understanding right here. OK, probably have to actually execute something. That's OK. Don't worry about the other file. If you've got more files, kind of everything that gets imported, because it kind of starts out from where the tests are going. So you see in this case, only half the functions, half the statements, and we've got these uncovered lines. Well, we kind of get the functions part, so let's not distract ourselves with this. Now, sure, what you can do is you can look at those uncovered lines here, and you can track that down. However, another thing you can do, and we mentioned this in the slides for you, is that when you run this coverage command, there is a folder that should be created here, which you'll see called coverage. So you see this folder called coverage. That folder, if I go inside of it, we'll have another folder called lcov report, which will there have a bunch of stuff. I don't know if I can open up. Can I open up Chrome from the terminal? It's all good, guys. Sorry, let me just grab this real quick. So if I go to like 1.5, yep, and then I go to this folder. So you can do this in your own Explorer, right? Whether you're on Windows or Mac. You go find that file here, this index.html. You grab it and you simply drag it up here. And what this file does is this file is it's a web page that's generated by the coverage command. And what it does is it goes and gives you a bit more of a graphical summary of things, which can be really useful. So for instance, here I click on is leap year, and now it actually shows me where the code didn't execute. So it shows that, yep, line 3 didn't execute, and these lines didn't execute, and that line didn't execute. Yeah.
Have like a TypeScript interface for something that doesn't actually execute. Is that gonna is just gonna account for that?
Yes, I don't know how though. I don't know if it ignores it outright. I'm not sure if it just transpiles it, then runs the JavaScript, or I'm not sure if it executes it once it infers the type. If that makes sense. Like if you, for instance, if you have a function again called blah, and imagine that blah has a type called some type x equals int or string, right? And then here you say, yep, b is type x. I'm not sure if it just ignores that type or if it covers it when the function is called because it had to infer the type. But because TypeScript's statically compiled, right, by the time Jest would ever run something, TypeScript's already checked it. So I more likely imagine it just ignores it because, like, if it's kind of TypeScript, if it's made it to the Jest point, then the TypeScript's valid and it doesn't really matter too much. But, yeah. Yep.
What about functions that are not exported? Like just functions inside the file which you don't want to.
What about functions that aren't exported? What about, that are just in the file? Well, they should be covered because other functions in that file are calling them, right? So if you have a helper, it's a great question. Like if you have a helper function up here called blah, then at some point in that function, if it's not exported, you would imagine that some other function is calling it. So that if it's Jest will cover it because it covers this is leap year. So when it calls like one function like is leap year, your other functions will call the helper functions, if that makes sense. Obviously, if you have a function in your code that isn't exported and no one uses it, it's a literal unused function, then yeah, it will come up as like uncovered, right? Because no one's covered it. Usually, like in a course this small, we'd probably say like if you have a function that's never used by anything, you should just get rid of it. In the real world, that happens, that there might be an unused function. Maybe it's something that they've commented out, for instance, and they want to leave it there for like a week while they test something. In those cases, and I don't know what it is for Jest, but there's usually kind of comment signifiers you can leave, like, Jest, if you do something like this, Jest coverage ignored, that's not what it would be, but usually Jest will have these things where it knows how to ignore certain, like the linting as well, for sure. It's a great question. So why this is useful, and you don't have to do this in iteration 2. There's no marks for like code coverage in iteration 2. There are marks for test coverage, right? Your tutor looks and says, does it look like your tests roughly check in all the routes? It's very high level. It's something you could do too. But there's no numerical analysis that you get really any aggressive marking on in iteration 2. But in iteration 3, there is. So if you're in iteration 3, right, imagine we start iteration 3 next week. The first thing your group might do is run code coverage. And you find out that your code is like 92% covered. OK, well, now you go and figure out what other tests you have to write. So in this case, imagine that you're writing these tests and you're like, oh my God, oh, it's not working. Oh, OK, we've got problems here. So what do? You reason with it. You think, well, OK, if year is not divisible by 4, so you think, oh, OK, well, we simply have no, I mean, you would figure this out pretty quick. We simply have no case of like 2003 or something. Now, naturally, you'd probably break these up into their own tests, just to be clear. You'd have like, tests for like, divisible by 100 and divisible by 400 and like odd numbers and stuff. I'm just writing it in one block here, but you would probably break it up. And then you go and add your extra test, and then you simply come back to this, the folder. I go and run my coverage again. OK, now I can see that the coverage is up to 62.5%. That's better than 50%. And if I just go back to my web page, you don't need to find it in your browser, in your Explorer again, because all the coverage tool has done is just regenerated that page. So I can just hit refresh on this page now, right? You can just leave that up in the browser and keep hitting refresh. And I think, oh, cool, OK, I've done another one. What's the other case here? I've got a case where the years, what is that? If the year is not divisible by 100. OK, we've covered that case. If it's not divisible by 4, sure. But we haven't covered the case where it's not divisible by 400. So what that means is like 2008 is divisible by 4, but it's not divisible by 100. So that's where that got covered. The next one could be if we're not, what is it? If it's divisible by 400. So we might need to do the year 2000. So we can try that one again too. Cool, we're at 87%. We've kind of covered more. And then we need one where it's like, what is that? It's like not divisible by 4, or it is divisible. Stuff's so confusing to me. What is that? So it is divisible by 4, is divisible by 100, but not divisible by 400. So what that means is, and hopefully many of you live to this year, 2100. 2100 is not a leap year, right? Because it's basically every 4 years is a leap year unless it's divisible by 100. Then it's not a leap year. Unless it's divisible by 400, then it is a leap year. So that one should now not be a leap year. So now we can do false there, and we can run this, and we get 100%. Everything's 100%. Now here's an important distinction. Imagine I write my test wrong, because 2100 should not be a leap year. But let's imagine I do and expect that it is, and then I run my code again. Well, what's going to happen now is that we fail our test, but we have 100% test coverage, code coverage, sorry. And that's an important distinction to make, because like code coverage is a measure of how much of your code is touched. It has nothing to do with how successful your tests are. And all this tells us now is that our tests do look at all the code. This doesn't mean that your code is bug-free or anything, but it does mean that your tests have tried to explore every part of the code, which is a great measure generally for, it's a proxy measure for the quality of your tests. What you'll also notice here is this one called branch. Lines and statements are pretty much the same. The distinction there is like, I haven't really ever explained this in a lecture. Let me see if I've got this right here. Oh, sorry, it's the wrong thing. Usually what that means is, let's actually get rid of a couple of tests here. So let's just run that again. So let's say in this case we've got 62% lines and 62% statements, and the ones that we have missed are those two lines. So usually if I say, bring that up there, I should get a different result. Yeah. So a statement, there's a like a programming language definition of what a statement is in programming, right? But lines is what you'd expect as lines. Generally, statements and lines should be the same number if you've written decent code. Like this is not very clean code here, bunching that all up. A statement's typically like a line that should be executed. So I'd say don't overthink that part. Like statements and lines are generally the same thing if you've written good code, because each statement should be on its own line. Functions you get. Branches are slightly more interesting. Branches is a measure of, and we talk about this more in the slides, but I'll jump ahead. Your code can be broken down by basically a series of like while loops, for loops, if statements, else statements, right? And what I mean by that is if I go and put like a console log here, say I put like a bunch of console logs. See how the last results were that we covered 63% of statements and 50% of branches. If I now run this again, what you'll see is that we've still only covered 50% of branches, but we've covered 20% of statements. The reason for that's kind of obvious. It's because this is never, that's not, I should put that on the other side. I kind of meant to flip those around. So if we come back here, 63% of statements, 50% of branches, I run it again, and then what I get is 87% of statements and 50% of branches, right? So just by adding more lines of code, my statement percentage has gone way up, but my branches one stayed the same. That's because branches is a measure of how many if-else statements, how many different kind of like scenarios do you have through this function, right? Because obviously when you enter this function, you're always going to go through the console logs every time. But then you've got this if statement and else, if, else, if, else. So you've essentially got 4 ways through that function. It doesn't matter how many lines of code there are between the function and the branching, there's only 4 ways through the function. Now, the reason that sometimes branch coverage is a really great measure is because branch coverage is somewhat static to an increase in the number of lines of code. And what I mean by that is if I have a lot of code there and I run this again, you could be like, oh my God, I'm like 97% covered. Great, like good on me. But you've actually haven't explored half of the possibilities of what this function can do. So branching coverage is quite important because it generally denotes risk a lot better. Because there's not really going to be much risk in like one line after another, because typically all the branching you do covers all those same lines anyway. So branching coverage is super valuable in a general context. Here's the catch of it though. The way, and again, I think we'll probably get someone to review this for next term, but the way that jest coverage works is there's some strange quirks with it to do with branching. We experimented with this a couple years ago, and we found out that jest branch had just some, like without going into it, some oddities. So whilst branch coverage is actually a really great measure, in this course we do statement coverage. So that was more like me teaching, like this is like a broader idea you should aim for. But in 1531 for weeks 8, 9, and 10, a very short space of your life, we'll be looking at statement coverage, just because it's easier to test. And generally also, no one really has fat functions that have like, in this course, no one's got functions that have like 30 lines of code that don't have if, else, or while loops in them generally, There's like if statements and else statements everywhere.
Does that mean it's not like unreasonable that you won't hit 100% statement coverage though? Like in our tests for iteration 3, like is 90 okay? Or do you want to go for 100?
Yeah, like so. I mean, we'll talk about it next week. But generally speaking, you know how like in iteration 2, it's like your tests times by our tests. That's like your result, right? Plus linting, but let's forget about linting. That's your like auto mark result. In iteration 3, what we do is we then multiply that by coverage cubed, and basically coverage is a score between, call it like 0 and 1, right? And you might have like 0.88, 0.92. But the thing is, like, even those of you who've written really poor tests, your coverage is probably still at like 80%, because one test will typically go through a lot of the function anyway, right? So the reason we do that is because like generally, and I'm just pulling numbers up here, but 70% coverage is like pretty bad, pretty poor effort, because you don't need many tests to get good statement coverage in your code. And then like 80% coverage is like okay, 90% coverage is like, yeah, doing good-ish. 95% is like, yeah, good. 98% is like pretty good. And then 100% is like, perfect kind of thing. And the point is that this is maybe a poor explanation, but going from like 70 to 90 is easier than going from like 90 to 100. Just because getting those last niggly bits, like I don't know if, I'm not a mathematician, but it's got that like logarithmic feeling to it, right? Where it's like, it's hard, it's more and more effort to get down to those last bits. So because of that, what we end up doing is we actually cube your coverage score in iteration 3. And what that means is like, if you say get like, and I can do this in the browser a bit easier, is if you get like 0.7, your actual coverage mark is 34%. Whereas if you get like 0.8, your coverage mark is 50%, and 0.9, your coverage mark 73%, and 0.95, your coverage mark's 85%, and 0.98, it's 95%, and 1 is 100%. So the cube element there kind of actually correlates your coverage number to effort, if that makes sense, because it's so easy to get to 70, and then kind of exponentially harder to get towards the end. But your question, who'd ask the question? Yeah, okay. Your question was about, do we aim for 100%? It's like, yeah, you want to aim for 100%. Though there are lines you can ignore coverage on if you need to, because some lines just, depending on some implementations students have, sometimes there's like a random function that they needed to add that never gets called, and it's just not giving you 100%. So if you talk to tutors are allowed to like endorse you to exclude certain functions or lines from coverage if you feel like it's impossible. They can just approve the comment being added in. Because I think this is an important note too, is that the auto marker, we don't really mention this, but the auto marker will trawl your code for any git ignore lines or TypeScript ignore lines or coverage ignore lines and stuff. And it does get flagged with your tutor. So for instance, let's say there's going to be one group in iteration 2 in the course that puts a bunch of linting ignore lines in somewhere, or they put that little thing at the top of the file, with ESLint where you can ignore the whole file. Has anyone ever seen that? Don't look for it. It's fine. They look for that too, so there'd be a similar thing with coverage. And then your tutor's like, oh yeah, I okayed that, or they're like, no, I didn't okay that. Bit of a rambly answer, but. We talked about branch coverage. We don't do branch coverage in this course, but keep an eye out for it after the course. We'd love to do it in this course. Okay, so summary is code coverage is useful. It's more important to look at what's not covered than the coverage percentage. Yeah, that's true. Obviously, from an auto marking perspective in iteration 3, we do look at the coverage percentage. But what we're trying to say there is that, if someone said to you, oh, our code's 85% covered in general, you would typically be like, well, what's not covered, Because again, 1531, tiny project. I know the project feels big because, it's 10 weeks and it's like the most of the course. But grand scheme of things, your project's a pretty small piece of code. if you're working on a very large code base in a corporate, the point there is that there's certain code that can break and there's certain code that can't break. You know, like a good example is that, you know, say like the startup I run, we have pieces of code. Like we hold many millions of dollars of people's money, right? And as part of that, we have to make sure that our systems that tally that up and, you know, subtract it and manage the deposits and withdrawals, that they work okay. We need to make sure that code works. So if you were, say, looking at code coverage of that, you would go, well, you know, if that is only 90% covered, that would be a big deal because you've got 10% of this critical system that's not covered. So that matters a lot. Whereas if you've got some random thing over here, some random web page, like some contact us page that you've built, and, you know, someone hasn't tested it super thoroughly and the coverage is 70%, you would, or like the coverage is 70%, you would say that the like 90% on a critical system is way worse a situation than the 70% on an uncritical system. Again, everything in your project is small enough that you couldn't really discern critical from non-critical systems, but the point of that line is that, you know, bigger picture stuff, don't just be like, oh, it's a percentage. Actually dig into like, what is this? How critical is it? What could go wrong with it? Any questions?
So outside of this, branch coverage is generally more as opposed to statement?
Yes, yeah. I mean, they're both, you know, you could argue that they're both important. And but it's more like, if you really pay attention to code, errors happen typically from loops not being entered by a test, or if statements or else statements. It's typically like the path not followed, that the input you wrote in your tests never went into a particular whole chunk of the code. And where it gets really, actually a good example, thanks for asking the follow-up, is sometimes you can have code like this that's like, if A, then do B, C, D, E, F, G, else do H, right? And if you only ever pass an input that is truthy for A, you'll like never see this whole other half, you know. And maybe in reality, this is actually like what a user ends up in 50% of the time. But if you look at just statement coverage is going to think you're like 90% covered because you like got through all these lines here. But yeah, so that's mostly what it's relevant for, because bugs will happen on the lack of branching that you check. Cool. All right. Well, let's take a 7-minute break. 11:55. Then we'll keep going. Yeah. Talk about deployment. Very light lecture to finish up today. Hi, everyone. Does anyone watch Formula One? Anyone a Formula One fan? I'm not a massive, I don't really watch it much, but I was in the mood last night to stay up and watch it, and it was a very good race. So I regretted that early this morning. But for any fans out there, I hope you watched it too. Hello. All right, we're going to get stuck back into it. Okay. Fun topic. Deployment. So deployment is a very loaded term. There's a lot of layers to it. The purpose of this lecture on deployment is when we write software, most software you write as an engineer will be for people to use. You know, as engineers, we apply principles of science and our understanding of the world to solve problems for real people out there. Every app you use is a human app, right? That's the fun thing about engineering. It's a very human activity in nature. It's all about people at the end of the day. However, at this point in your uni degree, all the software that you've written, often useful for people, right? Maybe it's a game, maybe it's something in 1511 or 1521 or 2521. Maybe some of it's not too useful. But you've never actually been able to make something and then give it to someone, right? Like all your software has just existed in a little vacuum on your computer to die with you, if that makes sense. And because most software that we write is for people to use one day, we need to understand that there are processes involved that make it available to people to use. And what I mean by that is you think about some app you use on your phone, like Spotify or something, or Spotify releases a new feature. Someone at Spotify works on something, and then they make that available to you and your family and your friends, right? That whole experience is what we call deploying software. We take software we've written and we deploy it out there to the real world with people that we write it for, and we refer to that process as making software available for use. We're going to talk a little bit about deployment history, and then we're going to talk about automation processes around it, and a few other tidbits. It's a very high-level lecture, so not a lot of hard programming. Some people like that, some people don't. Deployment's a really hard thing to do practically. We do introduce it in the course in a fun way, I believe, unless something's changed. But firstly, let's just talk about it. So I mentioned deployment, activities relating to making software available for use. Makes sense. I have software, I want it to be available for you to use. I have to deploy it to you. The cool thing about deployment is it's just a concept. You can deploy things a million different ways, at a million different scales. There's deploying software for just you at home. There's deploying software that we deploy out things to you as a cohort. There's Google deploying out a new version of Google Search. They would be pushing out a new version of Google Search every day or every week or something like that. So all these things are happening. But one of my favorite ways to demonstrate this is because let's imagine for a second that I have a file on my computer in this folder, and it's going to be called page.html. Just a simple HTML page. It doesn't really matter what it is. This is just one thing. And this page is going to say, hello, what's my friend at the front who's asked some good questions? Flynn. Is that with a Y? Excellent. So I've written a little web page here called Hello Flynn. And what I can do is I can actually go and load up that page. What did I call it? Page.html. I can go and load up that page. You can open any page on your computer, just try dumping it in the browser, right? You can dump in a text file or a PDF a lot of the time. In this case, I'm just dumping an HTML file in there. Now, if I'm feeling like a really adventurous web programmer, I can go make Flynn bold, which would be super fun. And I could also go and make Flynn fly across the screen if I also want to, right? Now, that's as deep as we're going to go playing around with web stuff. But the point is, I've written an amazing piece of software here, and I would like everyone, Flynn's friends, Flynn's family, everyone else in Flynn's course to experience this as well. But the problem is, this is a file on my computer. So how could I share this with people? Well, I could go and put it on Google Drive or something and share a link around to the course. I could email it to all of you. you could argue in a way that that's a extremely rudimentary version of deployment by the definition of making software available for use, right? If this is software, I want to make it available for other people to use, so I could email it to you. However, another way you could do it, which kind of is, because that's a bit of a BS way, right? Emailing it as deploying software, is that in everyone's CSE accounts, all of you, obviously I'm logging in with a name here, but you'll have like your Z number, you know how to SSH into your account. All of you will have a folder. Oh no, I did it again. I'm on my hotspot. What have I done? What have I burned through? 4 gig. Oh. This happened. Connection successful. Hi everyone. I hope you can hear me. Oh, okay, I got to re-log into SSH now. Thanks for that. Does anyone else out there do that thing where you buy like a really cheap data plan and then you try not to use too much data? Is anyone like me? Yeah, a couple of nods. It's like that. So that just like hurt. That was like 2 weeks of data savings out the window for your benefit. All right, so every time you SSH into your account, you can go into a folder called public HTML. You'll all have this by default. And in that folder, anything you put in there will be made public. So in this case, what I'm actually going to do is I'm going to go and actually just SCP. SCP is a way to like transfer a file over SSH. So I can basically say, I want to send page.html to my CSE account. And all you do is you put your SSH, name and whatever there. You put a colon, and then you tell it the folder you want to send it to, which is just public HTML. And what that will do is that will simply, from my local computer here, send that to CSE straight up. Cool. Now, what I do have to do on CSE typically, and what I can do now is if I, on my web browser, you can actually navigate to you can do this yourself, right? So if you put something in your public HTML folder, and then you navigate to cgi.csc.unsw.edu.au, tilde your Z number, / whatever file is there, right? It's just a folder. So don't overthink it. I put a file called page.html in that folder. This won't work, but it will try and work. Or did work. There you go. Probably already used this before. Sometimes you have to play with the permissions. I probably have done that before, but sometimes you have to like you have to run this command on the file to like give it the right permissions, just in case anyone really tries that out. But now what you'll see is that this is a page that exists on the internet. If Flynn from Sweden, you're not from Sweden, but if you were in Sweden, then you could go to that URL and you could see that page, right? Anywhere in the world now, it's on the internet. Just it's a quirk of how CSE's servers are set up and how your accounts work. Obviously, don't put anything stupid there, like a downloaded movie or something, and share it with your friends, because every time you SSH in, you do see those policies that are like you'll end up in prison and stuff. But that is there, and that's now available for use, right? But here's an idea of deployment. Deployment's meant to be a way to help automate and simplify that. So imagine that I think, well, actually, you know what? I want to do more on that page. I want to also say hello to, what's my quiet friend up the front? What's your name? Omar? Is that O-M-A-R? Or O-M-R-A-N. Okay, okay, cool, excellent. So, is that okay? Yes, excellent. So, now I've got that, but naturally if I go and refresh my page, it's not there because it's just on my computer. So how do I make it available for use? I run my deployment command, and it runs, and now it's up on the internet, and give it a sec. Now it's there forever, right? So what you've seen, and I like this example because all of you can do it, in your own time really easily, is you've seen like we write software, we're happy with it, we've tested it, whatever you will, and then we make it available for use. And that is the principle that informs most software engineering. It's just at a scale that is difficult to comprehend in some companies, right? And a complexity that involves, at the top end of town, like teams of people just full-time focusing on trying to get it available. So that's like the very bottom end of the spectrum. They're floating at different speeds. That's kind of funny. But that's making software available for use, right? We could do anything that we would like to there. So basic deployment, we tried that out, cool. So a bit of the history first, because this is really, really important. Historically, deployment was much less frequent and much more physical. I know that you're all, I'm like 30 for context, and a lot of you are probably going to be about, what, like 20-ish, give or take a year, be my guess. So I know that you're not so young that you don't remember, picking up lots of CDs or video games or something, right? Whether it's like music or video games are still in cartridges and little things and stuff. But there's stuff when you go back, lots of software wasn't collected off the internet when you were probably quite young, right? What that meant is that people would typically work on code for a long period of time, and then they would make it available for use in one big chunk, right? Your really classic examples are like most video games, honestly, till quite recently, because video games actually often haven't had as much revolution with the digital stuff. But that's why if you go back, you look, and there's a whole bunch of video games from the 90s that are like broken, and people can like hack them and like toy with them and break them, because like they literally spent 2 years working on it, and then they put it on a CD, and then they shipped it out to the world. You go back to the older version of Windows, right? Major updates to things like Windows and Mac OS X, they used to come in like yearly chunks. There'd be like a problem, and they'd be like, well, now we got to fix it in the next version. It's like Windows XP, which is that old version of Windows, had like 4 versions of it that came out. So that was kind of how software was made available. And a big part of that was, I don't know if I mentioned it here. Yeah, a big part of that was basically just that the internet was slow, really. It just wasn't like possible. I have a TV, like my main monitor at home is like a big TV, and like I like turned it on last night, and it said to me, it's like, we have a new software update to download. It's like 1.2 gigabytes. And I was like, my God, my TV needs like a 1.2 gigabyte. This is like a shitty Aldi TV, right? I was like, this thing is massive, right? That wouldn't have happened 15 years ago. So through the 70s, 80s, 90s, 2000s even, everything just had to be done physically, right? In some cases you might maybe be able to download something and plug it into the TV, because the TV 15 years ago wasn't connected to the internet. I didn't even know my TV was connected to my Wi-Fi, but apparently it was on my Wi-Fi, right? So deployment's very different, but something changed over the last 10 to 15 years, 2 things in particular. One was the increased prevalence of web-based apps, and the other one is the improvement to internet connectivity, speed, and bandwidth. The internet one you kind of get. Internet became cheaper. It became faster. You could do a lot more with it. You can kind of download anything now. If I said to you, you got to download a 3 gigabyte file, you just download it. You wouldn't really overthink it. The uni internet's really fast. If anyone's ever benchmarked it, it's like exceptionally fast. It's like, it's been top end like NBN for a long time, even before that was around. But the second part's really important. It's the increased prevalence of web-based apps. So if you go back, again, like 10 or 15 years, most software you were using on your computer was based on, it was its own app, right? If you wanted to install Spotify, you would have to download the Spotify app. If you wanted to use, obviously you've got like Chrome and Firefox. What's an example of an app people used to download that they don't anymore? Someone's got an idea. I'm sure. You only have to answer one question today, guys. It's just this one. Word processor? Yeah, it's a perfect example, right? Who actually has Office on their computer anymore? I mean, some of you will, right? I do as well. But it's like Google Drive, Google Docs, Google Slides, Canva. Think about the sea change that is. Most people these days are making presentations on Canva or Google Slides or something in the web browser. And the reason the web browser is really interesting is because when you load up a page in the web browser, nothing's really installed on your computer. It's nearly like you're downloading the app, so to speak, every time you load that web page up. And what that meant is that from a software availability perspective, the shift went from like, oh, we have to package this up, put it on a website, someone's got to download a version of it, and then we have to remind them to update it later, to like every time someone goes to canva.com, they're just getting the latest version of Canva. No one's saving anything, no one's installing anything. So between that, the power of web browsers and the speed of the internet, massive shift in the last 15 years that most software now is just like a web-based app that is deployed, as in people write it on their machines locally. Take Canva as a good example. 3,000 or so engineers, they all write on this one code base every day. I don't know the exact cadence, haven't chatted to them in a while. They will go and push that up to their servers in the cloud, and every time they're like, millions and millions of customers access Canva, they're just talking to those servers in the cloud. So there's a really fluid experience of what deployment is, which is typically, daily getting it up there. There's no more CDs being shipped out. There's no more like canva.exe or canva.dmgs being downloaded. And that's really changed how we deploy software from 20 years ago. To it's deployed quite often all the time now. So it's so fluid. It's iterative, it's fluid. You can look at it any different way you want. And we have seen that movement from software as an asset to software as a service. A really good example of that too, and again, I know you're all going to be old enough to have paid attention, is like there was a period where both Apple and Microsoft had adjusted their operating systems to basically allow you to upgrade versions of OS X or Windows kind of just forever now, like Windows 10, I'm not too familiar with where it happened with Apple because I've mostly used Windows in my life, but like Windows 10 was kind of the last operating system anyone had to install, Windows 11 was the first time that Windows just said, actually, you know what? We're just going to like literally send stuff over the internet to your computer and like reshape your whole computer. No CDs required, nothing like that. It's just all through updates now. Your phones have been doing that for a long time. Androids and iPhones got into that way early. You didn't have to like go and buy like the new version of iOS from like the store and like plug it in. It just kind of kept updating. So massive changes. I'm just talking in circles about a whole bunch of different things. But this is why this topic is really big, and that's why it's very different to what it was a while ago. Yeah, we get all that. I just kind of talked about it. Cloud services underpin this. Because the world is predominantly web now, and everyone's accessing stuff in real time, should update a couple of those. You have massive cloud services now where so much of the software we use day to day, Spotify, Microsoft Teams, Netflix, whatever, are all just hosted on these big cloud providers. This is where we deploy our code to most of the time now. The biggest cloud providers at the moment are not what's on the slide. That's outdated. I apologize. It's Amazon Web Services. That's the arm of Amazon that has tried to do cloud storage. They got a head start on the industry. For a long time, they were just extremely dominant. You've got Azure, which is the Microsoft one. Azure is very popular in the kind of corporate land. So very large companies, I don't know, but examples would be like Telstra or like Boeing or Qantas or something might be using those ones. Like they're very good at their big scale commercial agreements. Amazon's a bit more across the board from like large scales like Netflix down through to small companies. And then you have Google Cloud Platform, which is Google's one. It used to be called App Engine a very long time ago. It's a very old slide now. Google Cloud Platform is Google's one. And they're kind of coming in at the moment with absolute vengeance, trying to take over the world again. They're kind of your three big hitters in the world of cloud, where things are deployed to. Under that, you have a range of like, I guess you'd call it like indie providers, like Heroku. There's another one called Vercel, which is becoming popular. That's what we actually get you to use when you deploy in this course. And they more tackle that like, sometimes you'd refer to them as like SMEs, like small and medium enterprise business, where like you wouldn't see a large company like say Canva ever deploying on Heroku, or Vercel probably at this stage. They're on the big hitters, but these ones are really popular for things like uni projects and small organizations or like startups trying to get going and things like that. So there's a whole bunch of these cloud services that underpin it. We don't really spend any time on that in this course. It's more just saying that typically that's where your software is made available. It's through a cloud provider. And all a cloud provider is like a server somewhere or an abstraction of a server somewhere, right? Like Amazon Web Services, they have a big warehouse in Sydney. I don't know where it is in Sydney exactly, but they've got a big building with a lot of computers and a lot of hard drives and a lot of network switches that like, because at the end of the day, all software that's on the cloud is sitting on a computer somewhere. It's just abstracted away from you. You might remember continuous integration back from UCHOW. I won't recap it because it was like 4 weeks ago, hopefully. But the reason we mention that is because continuous integration is, if you think about the concept of it, of like it's trying to consolidate code changes, run some checks, and put everything in master stably. The next thing that we have is continuous delivery, or continuous deployment, but just continuous delivery for now. It's another pipeline, if you will, that happens after continuous integration, which is like about once you have everything in master integrated, right? Because CI, continuous integration, is about getting code integrated safely in an automated way into master. Once it's there, you'll then typically have continuous delivery, which focuses on getting it out into production, out into the big bad world. It has bunches of different stages in it. You don't actually have to do much of it in the course at all. Just because the problem with teaching a lot of deployment stuff is that because it's a whole other field in and of itself, it's not really something that you can kind of test with people. You kind of just be like, here's some instructions how to do it, and people go do it, because we don't spend weeks on it. But we will get you to do a little bit of it. We'll talk about that in a bit. But continuous delivery as a concept is about allowing code changes that have been accepted, i.e. code that's ended up in master, to be deployed quickly and sustainably to customers. It's basically that kind of deployment process. This deployment, quote unquote, typically involves a release process such that someone actually presses a button, like a done button, if you will. Like they're like, yep, everything looks good. So continuous delivery is where we have automated systems that will like check it, get it ready, and then you hit the deploy button and it goes and sends it up to the cloud, just like that SCP command. You know how I had to actually hit enter on that SCP command, but then it did it all for me? Think of that like continuous delivery. It's like a very simple human behavior triggers an automated process that sends stuff out into the world. Many companies will, let me just double check where it is. Yeah, many companies will have processes around how they release stuff. We talk about this for a little bit now, which is, it totally depends on the company. But some companies will push out their code hourly. Some will push out code every time it ends up on master. Some will do it daily. Some will do it yearly. But not yearly, like weekly. It really depends on the company and what they're doing. A good example is I imagine companies like banks, just because of them being culturally risk averse and also having some good reasons to be risk averse, they would not be pushing out new versions of the CommBank app or Westpac app probably every single day. Maybe they do. I don't want to undermine them, but I would be surprised if they were, because why would they, right? It's a fairly unchanging app. Every time you push something, there's a chance you break something. Whereas on the other end, I think there was a company called Spaceship Voyager in my industry. Their old tech lead gave a talk a year ago and was talking about how they were pushing stuff out many times a day as they were getting work done. So it really depends on the organization. Some companies refer to this as shipping code. Atlassian is well known for kind of popularizing the term as like, shipping. They used to have their big kind of ship it hackathon, if you will. Where the idea, because like everyone, you probably know, like a hackathon is basically where a bunch of, people come together and try and make something, right? And Atlassian used to run they still do, sorry, is like this thing called Ship It, where they basically get employees in their company to come together for like a hackathon, but the purpose was to build something that you would then actually deploy out to customers, right? It wasn't just like go make something random. It was like you and 3 or 4 people go make something. We're actually going to push it into production, ship that code out. So that's kind of where that term comes from. You'll still see that referred to quite a bit as like shipping code, deploying code, shipping code, probably the main things. Releasing, yeah, different people would call it different things. This is a big topic, very theoretical again. Different companies approach things in different ways. When it comes to continuous delivery and the deployment of code, there's so many different ways you can go from like your computer to a production environment. One really simple example is what you might call like tiers or staging areas. There's a lot of different ways you could refer to it. what you saw when I did the simple public HTML example was like the flattest, dumbest deployment. It was like, there's my software, hit a button, now it's in production, we call it. Or it's live, right? Live or production would probably be the two main terms you'd hear about it as. And you can expand the gap between that as much as you want. And how much that gap is expanded and how many steps are in between that will typically depend on the scale of your operation, the sensitivity to failure of your operation, and the likelihood of failure of your operation. A good example is that medium-sized companies might have a few different tiers. A really simple example that you'll see quite often is you'll have companies that have their kind of development code. Every time the code ends up in master, that's their like latest development code. That's just on every employee's local computers. Then what they'll typically have is they'll have what they call a staging environment or a testing environment, which will be an actual deployed piece of code up on the internet that you can access that is meant to be kind of like a pre-release of production, like an early access that has the new features in it. And once they're happy with what's there, then they'll go and put it into actual production where it goes out to real customers. So the examples I kind of give are that, there's apps you use out there like Spotify. There's probably some website out there that you don't have access to that they'd make sure you don't, called like staging.spotify.com or test.spotify.com, which registered actual testers for Spotify or employees themselves of Spotify would actually maybe use before they release a new feature. It might be like a real website out there on the internet. Because obviously there's a balance where you want to get these things like as close as you can to production and really lifelike and take them in stages in case things go wrong, right? Because if things go wrong, you want to catch them before it affects a real customer. But if you break it up into too many steps, you just waste a huge amount of time. So again, that's really kind of case by case. But there's a journey to production that'll be different in every company. This is a really old slide. I only really talk about this one. Been talking about it for so many years now. I only really talk about it because I did an internship at Microsoft, so I kind of have some background with it. And I know they do something very similar now. I should really go find a new picture for it. But basically, the team I was adjacent when I was working at Microsoft, they were called the flighting team. And what I found so interesting about them was they were the first exposure I had to a team that had a really rigorous process of getting new software out. Because Windows is a good example of software that's on the other end of the spectrum. Think about how many computers out there are using Windows. If Windows is buggy, what the hell do you do, right? Like if Chrome's buggy, you just close Chrome. Maybe you open Safari or Firefox or something. Or if Spotify is buggy, you just do something else. If you're like Windows or Mac computer just doesn't work, you're in the real crapper at this point. So they have a really conservative process of getting software out, where the software they write, it's not going out that day necessarily. And this was kind of pulled from some of their documents a long time ago, probably like 8 years ago now, was that they kind of explain it. Again, the point here is not that this is like the best way to do it. The point here is that this is how much thought can go into these things. And what they had was Canary, which was their daily build. So basically at Microsoft, there's a repo of Windows, and every day that gets built like a C program, compiled overnight, and you can use that if you want. So a bunch of the engineers who are working on Windows are probably actually running like on a laptop or their laptop, the latest build of Windows as of the last code changes that day, because they're on the front lines working on the code. And then as you get further and further out of this, you get like less and less releases. So imagine every day there's a Canary build. And then at some point someone says, okay, this build is stable enough, we'll release it out to the next stage. And then they keep working on it like this. And then the next stage might get builds every 3 days, or here you go, like 3 per week, right? So everyone within kind of say the Windows group would then get this. And then later on, eventually, once something's stable enough, everyone in Microsoft would have to use it. So everyone who works at Microsoft, who's obviously probably using Windows, would have a version of Windows that is more new than the one you're using on your computer, because it's much better to piss off 50,000 Microsoft employees than it is to annoy you, right? And they have the capacity to report on it and work on things like that. So they've got a few stages there, and they've also got their there's a bunch of nerds out there who really love the new stuff on Windows. They're happy to get it on their computer so they can get some new feature even if it breaks. So they're also part of the picture as well. And this is really common in companies. Is Even in like our company, we have small groups of testers that just love new stuff, and we just give them the new stuff, and it's broken. They don't care. They're just excited. They're excited by the tech. They want the new features earlier. They want to play with it. They don't really care if the UI is broken or if something's a bit buggy. They'll just tell us and be like, this is a bit buggy. And we'll be like, thank you. That's great. Super helpful. So every organization and process of, I guess you can kind of imagine it as like people write code and then it's got to end up in the hand of a completely impatient, unforgiving user, the typical user. And then the journey in between's whatever it is. And this is just one particular journey. That was the case with Microsoft. I'm sure it's slightly different now. We've also talked a little bit about, we talked about continuous delivery, but there's another term we use called continuous deployment, which is a little bit confusing, but continuous deployment is basically where continuous delivery has an automated release process. And this one's actually probably more common. It's very common that if your code passes all of your continuous integration tests, why wouldn't you release it? Like, why do you need someone to manually press a button to release it? What are they going to bring to the table? Are they going to test it themselves? If you've passed all your Jest tests and you passed your TSC and your code's linted and like this and that, it's like, well, it's probably good enough to go into production. And if it's not good enough, you should probably write better tests or put more, stronger typing in your code. So a lot of deployment is actually done automatically. Which is when we call it then continuous deployment as opposed to continuous delivery. On top of this too, when it comes to this, mostly it's time-based. There's not a lot of companies I know that would be merging in code every master. It's quite often a daily thing is the most common one I see. Typically somewhere between like 8 p.m. and 7 a.m. Usually it's kind of like in the quiet fringes, and typically it's not whilst people are asleep. It'll typically be like a 8 p.m. to midnight thing, or like a 6 a.m. to 8 a.m. kind of thing, like get it early in the morning or late in the evening, where if something does go wrong, someone's working to catch it. But again, that's just kind of the mantle of companies in the middle. I'm not talking about the Googles of the world or the Microsofts, because like they would have way more complexity there. They've got teams around the world too. They wouldn't be constrained by things like time zones and who's awake, because someone's always awake at Google, right? That's why we have such big offices in Sydney with Google and stuff, because we're like with Asia. Random fact, I always, I love telling a story, even though it's a boring story, so just prime yourself for disappointment. But there was an ad I saw once that was like, it was the Western Australian government posted an ad, and they were trying to convince you to move your business to Perth. And I was like, that's a funny ad. And the ad basically said, it was very straight to the point. They just said, move your business to WA. We share a time zone with 60% of the world's population. And I was like, I never thought about that before. But it's like they've got the entirety of like China and India just like above them in the time zone. So anyway, yeah, thinking of deployment and stuff, this kind of things, these things do actually play into it quite a bit. I have a lot of friends at Google and stuff who are on shifts when it comes to like managing these systems, and they do handovers, right? Where like an Australian will work from 9 till 5, and then from 4 to 5, the Europeans wake up, right? And the Europeans will like log on at their 9 a.m. and there'll be like an hour overlap where they're like, this has been happening today, we're keeping an eye on this has been going on, and then the Europeans will work till the Americans wake up, and then that happens, then it's back to APAC again, and so forth. So crazy stuff. Not something I've spent a lot of time with because I've mostly been involved in small organizations, but really cool. Okay, so deploying software on your own. So we have changed up this. We used to use a service called Always Data, but they shut down, I think. I think they went bankrupt or something. I always have this guilty feeling in my head that after years of sending 1531 students there to use their free product without hitting the paid tier, that maybe we like bankrupted them or something. But it's actually really hard because we want to give you a chance to deploy software in this course, right? But the big services like Google Cloud Platform, Azure, Amazon Web Services, they're really complicated to use, right? I'm not saying you couldn't figure it out, but like if we asked you to do it, you'd just be like, it just take a lot of your time, unnecessarily. So we find simpler services to use, like the Herokus of the world or the Vercels. We used to use this one, but we now use Vercel. And we have a whole bunch of instructions for you in that. So because we want you to get some experience with deployment, but we don't want it to crush you, our approach has been, we have a set of very detailed instructions in, I can't remember if it's a lab, or I'm not sure where they ended up putting it, and a pre-recorded video that steps you through it, where it'll actually help you figure out how to deploy a lab and your major project with those very detailed instructions, and a lot of support on the forum too. So you will get a chance to deploy stuff in this course. Your project will need to be deployed for those final marks in iteration 3. That'll be in the spec next week. And you'll also need to deploy a lab, I believe, unless someone's changed that. They did change up the labs this term, but I wasn't involved in that at all, so I'm not too sure what's going on there. But again, very, very detailed instructions. Those simpler services are much easier to use. That's why we stick with them. Just another heads up too. So be very careful. I shouldn't have to say this, but we set all of this up that you don't need to pay money for anything, right? We have had, some incidents in the past where students have decided to go buy a paid plan when they don't need to, and we make it clear that you don't need to. And they've then run into problems actually having quite a big bill associated with this. We very intentionally pick services that you don't need to put a credit card into, just to be really clear. There's a lot of services like AWS, which are free. You can sign up to AWS for free, but they'll still take a credit card, right? It's like when you sign up to Netflix for your 30-day free trial or whatever, and they take a credit card because they're like, we think you'll stay. A lot of the big companies are like that too. So we tried very hard to figure out a process where we could give you access to deployment where they don't make you enter a credit card unless you actually want to pay for it, right? So it's all free. There's no credit cards involved. Keep your credit card away from these websites. Full stop. 99.5% of you will never you'll never put in your credit card anyway, you know what I mean? So don't worry about it. I need to say that now after something. So don't pay for it. It's all free. It's set up to be free. No issues at all. The only time you might run into problems is if your app does something really dumb, like it's got like a while true loop in it or something, or it's just like consuming resources. And then the website will be like, oh, you've run out of like deployment space because your app's really needy, And then it's like, do you want to upgrade so it runs properly? If you run into that scenario, the answer is not to give the company your credit card so that it just like charges you thousands of dollars for it. The answer is to talk to your tutor and be like, I think my project's broken. Can you help me out with it? And your tutor will help you out with it. So fairly easy stuff. All right, last few things. DevOps. To give you a sense of how evolving this space is, I would also, it's on my to-do list next time I teach this course, to update some of these too, because it evolves quite a lot. Good example. Even our industry is really young. I had this friend of mine. He actually helped me write the original 1531 update back in 2019. And I remember he said to me once, which I've never forgot, he was like, don't forget that we've only been programming for like 30 years and that we're still in the infancy, and we're going to look back in 50 years at everything we're doing today, and it's going to sound absolutely insane and stupid, and everything we were doing was pretty dumb. And I never really thought about that, the fact that we're like really just at the very early stages of like high-level programming in general. But the reason I mention that is because software as an industry is so young. Everything changes a lot, things evolve. A really good example is that many large companies used to have actually dedicated developer engineers and test engineers. You would actually be employed as like a test engineer. And again, at Microsoft, just because I was there, they restructured the company around 10 years ago to get rid of that and to just have engineers, because what they were finding was like, you go back to the 90s or whatever, it actually made sense that people would like build Windows for some months, and then a test engineer who's experienced with testing would come in and spend weeks ripping it apart, just because of how different software was. But because how software has changed and it's a lot more web-based and iterative and fluid, engineers like you and I now are having to do our testing and implementing together, because you can't just like write code for weeks and then hand it off to someone else. Things move too quickly for that. So the industry is always changing. I think that's like the most important thing, because I don't like getting up here with these slides and being like, this is what it is, because it's probably evolved slightly, and it's probably not even right, and every company will be different and won't even be anything like this in 10 years. But the purpose is that there's a particular area role called DevOps, which became popularized. I mentioned that example about development engineers and test engineers. There was also a very similar thing where you'd have like development engineers, test engineers, and system admins or something like that, right? And I had a friend who used to work at Optiva 10 years ago, and he started as a grad there, and he wasn't like a coder where he was like writing software, and he wasn't a trader where he was trading stocks on the NASDAQ. He was like a sysadmin equivalent, where his job was to help make sure that all the developers' programs that they wrote for the traders were like working, right? Like they had servers in the building. He was kind of deploying it, if you will. Like that was his like full-time job essentially. But those kinds of jobs have been, again, slowly phased out because everything is, again, getting tighter, right? Dev, test, deployment, it's all getting tighter and tighter. And DevOps is a term that describes basically that collapse, if you will, of deployment and operations and sysadmin and servers and Amazon and Azure and all that, and the developers who write JavaScript and things, bringing that closer together. Different companies will interpret this differently though. Sometimes it'll be interpreted as we need a DevOps role, which is someone who understands a bit of programming and a bit of operations, right? Basically, you get an engineer to work with Amazon Web Services so that the engineers can talk to them about it, right? Because it wouldn't be uncommon that like 20 years ago, you'd have someone working with servers who couldn't program, right? They could work with Windows and write terminal commands and stuff, but they didn't know anything about data structures and algorithms. That wasn't like their skill set. So, you know, a DevOps person might have a little bit of understanding of both. So they might like a lot of engineers, like one of my old friends from when I was studying, works at Canva now as one of their like senior sysadmins or whatever you will, right? Like they manage the Amazon, Google part of Canva, trying to get it out to people. But he's an engineer, so he'd spend a lot of time working with engineers. And it's really interesting because like you think about it, right? Classic example, you're managing Amazon Web Services. There's a big feature you have, right? You know, like GitHub. You've got like, or GitLab pipelines or something. It's you spending a lot of money. You need to bring that money spending down. Okay, well, you need someone in a DevOps role who's able to understand engineers and work with them to figure out like where can we optimize the cloud systems and where can we actually just optimize the code. So think of DevOps sometimes as a role. Other times it becomes more of a concept across various roles. So for instance, in this case, you know, Wikipedia, I know they don't say to quote it in school, but it's very useful to quote it, is a set of practices intended to reduce the time between committing a change to the system and the change being placed in normal production while ensuring high quality. So it's all about speed again. And sometimes we won't say, oh, we need a DevOps engineer. We won't hire a DevOps person, but you more end up now having a DevOps group or DevOps roles, right? Because if you're a product manager who is, you know, working on a product, say, what I mean by that is, you know, maybe you're someone with a design background or don't have a technical background, you're just kind of overseeing the product and quality controlling it and stuff. You need to be concerned with when it's getting released to customers because you're probably working with a marketing team, and the marketing team has to, who does their Spotify Wrapped every year? You know, I don't do that. You know that thing? I'm sure a bunch of you do it, lying fiends. Like when they release that, there's like product managers will sit down with engineers to actually get all the framing right? Like they'll get the frames right, make sure all the data's in it. They need to understand how it's getting rolled out to people so that they can work with marketing teams to understand how to send you push notifications about it, right? Because there's no point you getting a push notification 3 days after they've released it, and there's no point you getting a push notification 1 day before they've released it. So DevOps as an idea might actually be these roles where like product owners, team leads, the people actually running the cloud systems or deploying it are all working together as like the people responsible for that operation. So again, tricky little topic because it's just constantly changing and different companies approach it differently. But same point at the end, there's a little thing I included from Byte Go, just kind of cute. Yeah, talk about that in a sec. But DevOps, the term, it's a response to the collapsing of software teams, which are condensing down because of the aggressive iterative nature of software now, where we are releasing stuff every day. So Byte Go here has talked about, conventional software development lifecycle is like developer, quality assurance, release manager, goes out to the ops team to make it available, right? You get that. DevOps here, it's what we talk about. Developers, QAs, they're all working together to kind of continuously get stuff out. So that'll be like a good DevOps team there. But as an example of how this has evolved and why I've included some more slides here is like, there's this one that you hear talked about, which is NoOps, which is like, well, if you develop continuous integration pipelines well enough and you write tests well enough, and nowadays these cloud services are so well abstracted that you can literally, many times now, you can honestly get to a point with some of these services where you can just link them your GitLab repo and they will figure out how to do the npm installs and the npm starts, and they will just start up your server without you having to touch anything. You are seeing more and more companies actually have less of those operations teams in a weird kind of way and just be focused on building product, because those large cloud providers are getting better at it. Again, you go back 20 years, many companies were hosting things themselves in offices. Atlassian's a good example. I'm pretty sure they just used to have servers that they were running back in the early 2000s, where if you were using Jira or Confluence, like you were connecting to their servers. And they went through a big cloudification process where they moved everything off the cloud. And you're seeing this more and more as like, there's basically three types of companies in this space. There's the big guns like Google and Microsoft and Amazon. They've doubled down. They've realized that, you know what, they don't just run their own cloud service, because Google's run their own service forever, right? But they're just going to run everyone else's now. And they're like 100 times bigger in terms of their like infrastructure for servers. You have the medium-sized companies, think like Telstra's, and think, what would be, the Atlassians of the world, where they've been around a long time and they used to run all their own stuff, but they're not big enough to be their own server providers. So they've had to migrate all of their stuff across. UNSW is probably like that too. I'm sure UNSW has significantly less on-site equipment now, and they just use Microsoft stuff or Amazon stuff. And then you have smaller companies who've kind of come in the last 10 years, like Canva, and they came in after this revolution of cloud, and they've never hosted their own stuff probably. They just went straight onto these providers like AWS and whatnot, and they've just lived in the cloud forever. Just like you will as well. So again, very different stuff, because those different organizations will approach things differently.
Does it make sense to use like build a conventional one for some companies, or does everyone sort of strive to go to like the NoOps or the DevOps kind of way? Like the smaller companies, would it be better to do one over the other?
I'd say that like most companies nowadays would be like would be operating on a DevOps environment striving for NoOps, because like, Amazon, Google, Microsoft, they're experts in managing deployed systems. So nowadays, the people who oversee deployment are just people who are experts in the tools, A good example is like Google. Some of their new apps right now, you basically say to them, like, you can give them a code base of like a JavaScript thing, and you can basically say like, I have users in these countries, and what'll happen is that as like your users come online in Australia, they will actually spool up copies of servers in Australia for those users during the day, and then as that comes down, they'll like spool them up in Europe. Like, it's highly abstracted. So as that's happening, there's like, I guess you could say, a shift downwards, because you just need less people and that's less spend. But the interesting questions about the conventional software development lifecycle, there's a lot of industries that most of us won't go and work in. Some of us will, which is really cool, where you do need like a ridiculous degree of QA. A really good example of that would be software and airplanes. They're not like the code that runs on your airplane isn't pushed out every day. You know, it's like the stuff where they move the stick and the elevators at the back of the plane move. Like that stuff would be, I can't remember, but someone explained to me once that there's typically like a 30-to-1 test to code ratio with that stuff. Like they spend really little time writing the code and then it's just testing it for a long time and then they would just run it. Another good example is the Australian banking scene. A lot of, like, you know, when you, not the Pay ID stuff, right? We all know Pay ID and OSCO and those real-time payments. But there's the old stuff you do, like direct debits, or if you kind of pay to a super fund. You know when it takes a couple days for payments to work? You know, you send someone money, it takes a couple days. That's all on this stuff called BEX, which is the bulk electronic clearing system. And like that stuff, for instance, was, I think that's from the 80s. They still use that because like it just took so long to get it right. And they had to do so much testing on it. And even that Pay ID stuff, you know, the real-time payments we have now. I remember talking to someone who was like, they started kind of designing and building that in like the early 2000s. It took them like 20 years to actually get it in because if you screw up payments, everything's messed up. And in a way, software, we live in this weird world in engineering where we're allowed to break stuff and no one cares. You go to most other fields in engineering, these principles and things don't apply, right? Like, and we're quite tolerant of it as users, you know, like you log into an app, you know, you have an app on your phone and it's like broken today, and you're just like, yeah, and you like close it and you come back tomorrow and it's fine. We don't really have that in buildings and civil engineering. We don't have that in mechanics with our cars and our planes. We don't have that anywhere else. So this kind of movement away from like the more conventional style is like really software specific. And even then in the software world, particularly for low level stuff, I'd say it's still pretty common, or high risk stuff in general.
Really critical stuff, conventional, it's like...
Yeah, it can never break, right? Like you can never have an airline pilot, try to go up and the plane goes down. And I mean, you had that, right? Like you had that, like literally you think about the Boeing, you know, the Boeing 737 MAX -8, -9 stuff, where the plane like crashed into the ground. That was like a software bug, you know, where those planes drove into the ground. It was literally like the engineers wrote software. I mean, it was a bug with the sensors and stuff, but it was like there was a lot of software that would cause that plane to go down. And, you know, they probably didn't check that as much as they could, or there weren't the same quality assurance processes. So yeah, this whole conventional approach is still extremely common in the broader world. We live in a weird software bubble. Any other questions? Otherwise, we got one more slide to go. Okay, so last thing, the software development lifecycle that Yu-Chao talked about back in week 1. Requirements, design, development, testing, deployment, maintenance. Now, even the iterative process is just a really rapid version of that in many ways, slight variations, but they all still really matter, right? Like, I know we say like the standard software, like the standard one here, but if you pay attention, the DevOps one is actually just the standard one, largely kind of happening quite quickly. But there's the last part of that, right? Actually, I don't know if it's me or Yu-Chao, I can't remember where she put me to help her out this time, but we talk about, me or her talk about requirements next week. Can't remember. But after you get your requirements and you design it and you build it and you test it and you deploy it, it's all out with your users now. It's not done. You've got to keep going. Otherwise, you die as an organization, right? You have to keep improving. And there's two really important parts of this final step, which is maintenance and monitoring, which I've tried to break up into like preserving user experience and enhancing user experience. Because we're always making software for people. And once it's released to them, think about Spotify again, the two areas that you look to once you've released something are preserving, and preserving is in making sure that the experience is OK. Good examples here are like, are you getting errors on the server? How's the CPU load going? Like you have a lot of metrics that go on. You bet yourself that everything you do on all these apps the big apps in particular, like Spotify and Netflix, are aggressively tracked, right? YouTube's another great example of it. Even ad optimization. You know when you get ads on long YouTube videos, right? Like they are monitoring you constantly, not like you personally, you know what I mean? Like in aggregate. You know when something happens where it's really cool on YouTube, like what do a lot of people do? They kind of scroll down to the comments, right? It's a really common human behavior. Just scroll down, you're like, oh, I wonder what other people thought of that, you know? That is, like they would use things like that to figure out where to put their ads right before that happens, you know? Because like they're not always gonna know exactly like where the exciting point in the video is, right? They have to automate that at scale. So they're gonna, I mean, this isn't actually really fall well into this, but it's not really a good example of either. But the point is there's a lot of analytics that go on that aren't just that, but also like how's the server holding up? Is it too heavy? Is the user closing videos, right? Like they would be tracking, oh, actually we noticed that yesterday there was 7% less videos watched on YouTube. I wonder why that is. Maybe the server slowed down. Maybe a new piece of code that was introduced caused a lag somewhere. Or the new recommendation engine that was meant to give you better videos gave you worse videos, and therefore you watched less, and therefore they made less ad money, right? So after deployment, there's all this kind of monitoring that goes on to make sure they didn't F something up. But there's also another part that is about enhancing, which is like, how can they further improve it, right? Which might be like, what's the next step? So we think about the software development lifecycle. What's the next thing we can do to make it better, right? Like what's the next thing Spotify can do or Netflix can do or anything like that, really. I noticed there was an app, I don't remember what app it was, but there was an app recently that like introduced reacts, like you know when you like react to a message? There's an app on my phone, it never used to have it, and then it had it, and I was like, oh, that's really cool. Don't remember. But it would have been really good to have in the app. It's like, so all that stuff, whenever you're using an app, and there's a new feature added or a new exciting part of it, it's probably because what happened was at some point they deployed a previous version of code, and people that work in the team as like product managers and engineers were like, what can we do next? What can we learn from how people have used that latest version to add more to it? So we don't really talk about that monitoring and maintenance one just because there's not really a lot to it, but it's really just that step that says we've deployed it, what now? How do we keep going and start again? Yeah. Any other questions? Cool. All right, well, that's it for today. Thank you, everyone. I still have like 4 more lectures with you this term. I don't remember which